Okay, guys, let's go over this. So, Raven has an age. That equals x. 8 years ago, Raven was x minus 8. And 4 years from now, he is x plus 4. Twice as old as I was 8 years ago. 2x minus 8, 2 times his age 8 years ago, would be the same, equals, as his age 4 years from now. Then you just solve it. 2x minus 16 equals x plus 4. X equals 20. I'm going to make this a little bigger. The area of each polygon. Well, I did this. And then I said, okay, well, there's 4. So that's 4 plus 1, because each of them is a half. And I came to here, and I said that one was 4 plus 1, which is 5 again. And I came to this one, and I went 1, 2. That was easy. Then I went 3, 4, 5. Again. Then here, 1, 2, 3, 4 and a half. Then I went here, and I said 1, 2, 3, 4, 5 and a half, E. So we're going to rotate and reflect. So to get this guy to here, you could have rotated once this way. So this guy would be here, and then flipped him over, and he'd be here. So it was a rotate that way, and then a reflect that way. So now this is where I ended up, so I got a reverse. So I reflect left to there, and I rotate clockwise, counterclockwise instead of clockwise, to there, D. I just added all these up. I'm sure there's a trick, but I just added them up. 2 plus 3 plus 5 plus 7 plus 11 plus 13 plus 17 plus 19 plus 23 plus 29 plus 31. And then I just added them up. There's 60. There's 40. There's 30. There's 20. And there's 10. And you just added it all up to get 10 and 6 is 160. D. This one, you just do the math. 1 over W plus 1 over Z divided by 1 over W minus 1 over Z. Clean that up first. That is Z plus W over WZ. And that is Z minus W over WZ, which is then Z plus W over WZ times, you reciprocate that, WZ over Z minus W. Cancel, cancel. So now you have Z plus W over Z minus W. Now see, in this question, you need W to be positive. You need a positive W and a negative Z. Well, here you have no negative z's and you have a negative w, so you got to multiply that by -1. Multiply that by -1, you got to multiply the other side by -1 to get a. What do we know about this? We know that's 90. We know that's 9. We know that's 12. We know that's 8. We know that's 17. So when we do this, we know this side is 9 squared, which is 81, plus 12 squared, which is 144. So this side is 225, the square root of that, which is 15. So now I know this area is 9 times 12 divided by 2, which equals 54. And then this area, I don't know if this is a right angle triangle, so I check. 8 squared plus 15 squared equals 289. Square root of 289 equals 17. So this is a right angle triangle. So then I do 8 times 15 divided by 2, which equals 60. Then I add them to get 114. This set was tough here, or this question was tough. You had to read it all out. It explains it all here for you, though. So let's look at A. 1 plus 3, 1 plus 5, 1 plus 7. They all equal even numbers. So odd numbers are in the first set, and the sum set is all even. That's the set, that's the sum set. So since every time this is going to be even, but every number in the set is odd, A is sum free. So I have at least 1. Now let's check the rest. B, even numbers. Well, that's obviously not going to work because 2 plus 4 is 6. And then 2 plus 6, there's 6 in both sets. So B is out. C, prime numbers. 1 plus 3 is 4. 1 plus 5 is 6. 1 plus 7 is 8. You're going to get even numbers. But you got to remember that there's 1, 2 plus 3 is 5, and there it is in both sets. So C is out. D, set of squares. Well, we know it's out because 3 squared plus 4 squared equals 5 squared. And 25 is a square. So D is out. E, positive integers with the power, positive integer powers of 2. So 2 to the 1, 2 to the 2, 2 to the 3, and so on. That's going to be fine, except 2 squared plus 2 squared equals 2 cubed. 2 cubes in both. So E is out. F, all positive integer powers of 3. So 3 to the 1, 3 to the 2, 3 to the 3, and so on. But I got to remember that every one of these is odd. 3, 9, 27. But if I add 1, I'm going to get an even number. And I don't want to have that. I can't have that. So this is sum free. So that's the second one. So let's see. Okay, this one. 44 eggs to get 1 white egg. So that means he had to take 43 out. Of those, 4 are blue. So that means 39 are red. So if he wants a blue or a white egg, he might get all 39 reds, and then on the 40th, he'll get one of the others. This question is pretty tricky. There's the red triangle, which is 5 by 10. Then there's the blue triangle, which is x by 5. And then there's the green triangle, which is 2 by y. Now, all those are similar triangles, so compare them. 10 over 5 has to equal 5 over x. Cross multiply, x equals 2.5. Here, y has to equal 1. And this gray area is this triangle minus this triangle. So all I got to do is find the gray triangle, which is 5 by 2.5 over 2, and subtract out 1 by 2 over 2. And that gets me 5.25, which is 21 1/4. You can see my numbers are starting to disappear. I don't know what's going to happen here. I'm going to try closing, but of course it's not letting me, so I'll close this way. And I'll try reopening, and we'll see what happens. And number 10, I told you guys I'm pretty weak at this. So what I did was I dealt with the first 3, green, yellow, white, because all I know about white before yellow. So it has to be white, yellow. So the green could go there. The green could go there, or the green could go there. And then I just started putting in reds and blues. And when I counted it up, I got to 18. I think it's right. I don't know. But that's all I did. There might be a fancy math move, but I got 18. This one I'm pretty good at. Velocity equals distance times time, yes? There's 3 runners. So velocity of A, his distance was 24, and he completed it in some amount of time, right? So since he completed the whole thing, we're going to say he completed it in 1. B only was 18 in that same 1 time, and C was 15 in that same amount of time, right? So this guy needed to go 6 more, which was a third of this. So we had 1/3 of his time unit left, which means this guy also had 1/3 of his time unit left. So 1/3 of his time unit would have been 5. So he already did 15 in the first one, and then he did 5 more in his third of a time unit to get 20, which means he was 4K from finishing. And 12, honestly, guys, this is how far I got. I know there's got to be sides A, B, and C, and they've all got to be less than. And I know that A and B have to be greater than C or it won't work. And I know that A, B, and C can only be 1, 2, 3, or 4. So then I just started counting triangles. because 1, 1, 1 is okay. That makes a triangle and that works. 1, 1, 2, that makes a triangle and that works. And I just kept counting. And I got up to 10, but I don't know if that's right. There may be more, there may be less, because I didn't have time to check on similar or congruent. But I know like 2, 2, 2 and 4, 4, 4 are similar. So you can't count those, right? And 1, 1, 1. So I can only count the 1, 1, 1 guy. So I just started counting. I got up to 10, but I have a feeling it might be 9. I'm not sure which. I'm going to look it up tonight.